hopefully we're all running. Hey, you get on stream, you realise you haven't brushed your hair yet. So, hope everyone's all okay. I think I've started to get my system kind of sorted for these, but we'll still try to plough through and see how we get on. If anybody's in the chat, please drop a message. Yeah, the more messages, the better. The more questions, the better, as we go through this. And if you're watching this, of course, after our live stream, just keep dropping comments below in the comments, and I'll try to respond to as many as possible. So today's stream, I'm getting a lot of questions around the practical side of the exams, the CSWIP exams in particular, but just how they relate to real life inspections as well. So one of the things I thought we'd do is we'd take some samples. These are plastic samples like the CSWIP ones, so at least we're looking at roughly the same type of thing. They're not the samples you'll be using, but we can get all the same information from them, and defects will look the same way and do the same things. So we can play with that. The sort of the samples scare is the wrong word, but put a lot of people off and make a lot of people worry because they're not metal. Now, the main reason for that is consistency of samples. They don't give 100% consistency, but it's better if they were all metal. If we were to take, a classroom of 20 people who are on a CSWIP course, one course of 20, we would need 20 different metallic samples, which would not be the same. The exams would all be different, and then when you multiply that up by the amount of classes which are needed around the globe, then nobody would ever be doing the same thing. And best will in the world, making consistent defects and mastering them and being able to mark exams and things like that, it's a nightmare. So they've always been plastic, for as long as it really matters. It does mean, though, that the defects are fairly broad, are fairly open, and you can see them a mile off, right? So tip number one when you're doing any of this is to make sure that you hold the sample at about arm's length, and if you spin the sample round, or if you've got a plate, if you just look over the face and the root surface, any defects that stand out at you are the ones which are there. If you're sort of worried about, is it a defect, isn't it? If I hold it in this sort of light, I can kind of see it, but I can't always, then forget about it, right? The ranges applied to the acceptance criteria and when we master samples accounts for anything that might be on the borderline. You are going to see it. And I say to all my classes, you will fall into the defect if it's there, right? And if you've got a little torch, casting a shadow, which doesn't look too good on the camera, but for me, if I cast a shadow, I can start to see potentially where there's things catching the light, and they're going to be there. Okay, so that's number one. Hold it out, spin it round, take your time. Okay, don't be rushed. Tip number two is you have enough time, right? Was it an hour and 15 minutes currently for the plate? An hour and 45 minutes for the pipe. If you need an hour and 45 to inspect something like this, you're not doing it right, okay? So you have enough time. You have enough time to have a quick review, settle yourself, ask any questions, read the acceptance criteria, which is only one page. Come back to it, mark out your report, and move on. And we're going to talk about the report in a minute. The thing with the report is don't try to make it too beautiful, right? It's It's just a way of getting the sizes of the defects to answer our multi-choice questions. Okay, and that's that. Right. So I tend to approach this in a sort of a 3-stage process. First one, look at the sample, just get an idea what I'm dealing with. Next one, report the defects onto my report, which I'm going to show you how to do. And then put my main sample to one side. I can go back to it and look at it if need be, but for our first off, we're just going to kind of leave it there. I've got my report. I should be fairly accurate with what I need there. Okay. Once I get into my multi-choice questions, remembering that there's 20 questions. There's roughly 10 on the face and 10 on the root, but it might be 9 and 11, 11 and 9, but near on 50-50. 20 questions, 2 marks each, which means there's 40 marks in our exam, and we need 70% to pass. If we break down the sample and we just concentrate on the face and the root separately, we can almost imagine what defects we're going to see on the face as well, or on the root, which means that this whole bank of questions or defects that you have in your head about, oh, well, what happens if it's root pen? Well, who cares if you're on the face? You won't have that. You can just move on. Cut the amount of information that needs to be in your brain at any one time down as much as possible. And then from there, off we go. Yeah, so let's jump over and we will have a look at a sample. So I've tried to set up a sample here in the light as best as I can. One of the first things I'm going to invest in a little bit later is going to be a higher detail camera. Okay, so when we do these look downs, we can do more. I've got sets of macros and all sorts of things we want to look at moving forward. So we can, so we'll sort that out. But I believe you can see what we need to for the time being anyway, right? So on our report, what we've got is, you can see we've got A, B, and C. Okay, and these are shown within the sample. So we've got A, B, and C. Now, of course, because it's a pipe, it's going to go all the way around, and it's going to go D and then back to A again. Okay. The way the reports are made is you only do 2 sections at a time. So we're going to go A to B, B to C, and then on another section of the report, it'll go C, D, D, back to A. Right. But if we just do one half of it, we meet the whole thing anyway. Right. So what we've got, so we've got A, B, C, D. Normally, if I change the colour of my pen here, the B would have a line somewhere down like that, just to give you a position to measure off if you need be. And these are going to be our datums. So you can see we've got measure from this datum for the A side, then we would measure from this datum for the B, and then if we go and C into D, we'd measure from the C line. Okay, and again, you can see our datum line marked on our sample here nice and clearly. As you can imagine, the location of those lines are a little bit up for debate, right? It might be a bit thicker on some samples or not. It might be a bit more to the left, a bit more to the right. What that means is, in reality, the datum size doesn't matter too much. Okay, so don't worry about the datum size being bang on, right? We need to be measuring our defect sizes are the most important ones, okay? But as long as you can find your A, B, C, and D, and on the inside of a pipe, you'll see it marked on as well. It might go in a different direction to the outside. It doesn't matter. Just follow what you've got. Right? So if we then, so we look at that, and we can we can sort of start to transpose the defects we have on our sample onto our report. As I said before, one of the big things here is not to make it too complicated, right? It's a rough drawing, it's a rough sketch for you to be able to answer your multi-choices. So if you can read it, that's all I care about, right? Right. So if we have a look at our sample here, what we've got is from A, I can maybe see a bit of cluster porosity here. I come around, and hard to catch in the camera, but this area here, if I point at it with the pen here, may be slightly underfilled. If I feel it with my finger, I can actually feel it goes down a little bit. So I want to say cluster porosity, underfill here. Then I come around, and I've got, in this area is an arc strike. It's melting of the plate outside of the weld zone. Okay, and I come around a bit more, and I think that's pretty much it for that section, right? So I think I've identified 1, 2, 3 areas. So how am I going to write them onto my report? Well, the first one is our porosity. So again, I'm going to just change the color of my pen so it stands out a little bit more. I'm in section A to B. Now, things are not to scale. So if you just go, well, it's halfway between A to B on my sample, it wants to be halfway on A to B on my report, and then split it up like that, okay? The scale does not matter. Your measurements matter and what you're seeing the sizes are. So I can see that that cluster porosity on the screen there is fairly close to A. So what I'm going to do is I'm going to start with a line which is fairly close to A, like this. So I'm going to draw a line, and then I'm going to put my arrow in. So that's where my defect starts. I'm going to put a second line for where my defect ends, right? And then I'm going to write what my defect is. Now, again, it doesn't have to be pretty, okay? You get no marks for how clean your handwriting is or your spelling or anything like that. But I've got cluster porosity there, so I'm going to write cluster porosity. Right. If I then look at the acceptance criteria I've got, now I'm not bringing up the acceptance criteria here because there's too many things on the screen if I do that. But when you read your acceptance, what you'll see, there's probably something to do with cross-sectional area. And so we have to work out what that is. So the way we do it in our CSWIP exam, I'm busy looking for my ruler. I just had my ruler. Sorry, 2 seconds. I'll get my gauge. So I can take my gauge. You will have a bendy plastic rule, but I don't have one of those right now. So I'm just going to use the ruler on the side of my weld gauge. I can put this on to my part. And I'm going to say, what's that? It's about 8 millimeters by about 10 millimeters in size. So 8 times 10 is 80. So I can write cluster porosity 80 millimeter square. Okay, done. I might get to add a little bit more information, which is how big is the largest individual pore in that. And I'm going to look at it and say it's about, it's under a mil. It's somewhere between half a mil to a mil. So I might just put a note there saying pore size max 1 millimeter. Great. I've made that a little bit bigger in the writing than what I would normally, just hopefully so you can see it on the screen. But there's our information for our porosity. Move on. Move on. Very quick. Keeps us right. Okay. Now I can move around to my third section. So, our next section. And we said that was likely to be this bit of underfill that I've got here. Again, it doesn't come up the best on the screen, but I've got a bit there. So I can just stop that from rolling off the table, potentially. Come back to it. So it's on the bottom side of the weld, so I can come to my weld face here. and just draw it on the bottom. So here's my start of my defect, here's my end of my defect. Again, it's not to scale, it doesn't really matter. How far from my datum is it? So I can just take a quick measurement of that and say it's about 30 millimeters in from the datum. So on my datum line, I'm going to write 30 millimeters. And then I need the length of my defect, so I'm going to say that's about 8 millimeters long. And then what is it? It's underfill. Okay. By the looks of it, I've achieved sidewall fusion because I haven't got a straight prep edge. So I'm just going to say that I've got underfill at 8 millimeters, done. Right. Then I can come along and we said, well, our third area in that section was probably this quite big bit of arc strike. Now, arc strikes are a bit of a nightmare to measure because they go off in all sorts of different directions and things. So the CSWIP acceptance criteria asks you for areas of arc strikes, not sizes, right? So that means it becomes easier for us to donate on our report. So all we do here is we're just going to draw a box with our datum edge on it. I'm going to guess that because it's a bit longer than my ruler, and say it's about 100 mil from the end, and inside there I'm going to write arc strike. Okay, again, always keep it simple. You say I'm not worried if my box isn't particularly straight, my handwriting isn't brilliant, you know, it's just get the information down. So there, all of a sudden, we've been going, what, a couple of minutes, and we've already got the first quarter of the plate done. So this is why you have lots of time. In an hour and 45 minutes, stay calm, just keep moving forward. Then we can go B to C. So if I come round B to C, right. So again, in B, I've got a bit of cluster porosity there in the cap of my root. I come along, I've got this big bit of mechanical damage, which is probably a grinding mark or something like that. But down here, again, slightly hard to see in the light. Try to move it around so you can see it. I've got a bit of undercut. And then again, nothing really much else in there to be concerned about. So bring it back, come back to here. Again, our first defect is our porosity. So I'm going to draw my two lines, put my arrow in. What's my datum? Datum was about 50 mil. Cluster porosity. I want to say it's the distance of that's maybe again 10 by 8, something like that. So we'll say 18 millimeters again. Pour max 1 millimeter. Okay, and you'll have different things on your report, but just make quick decisions. You'd be amazed at how accurate you can actually be by saying, well, how big is that? It's about a mil, or it's less than a mil, or whatever. Okay, we then spin that back round and we come to our mechanical damage up at the top here. Just like with our arc strikes, we're just going to draw a box, put our datum edge on it. Again, distance from B, because that's my new datum. Again, let's say that's 100 mil, just for ease. Now, it's not an arc strike, it's mechanical damage. So I'm just going to put mech damage in there. Okay. By not worrying if it's is it a grinder mark, is it a chip and hammer mark, is it a dint? Who cares, right? It's mechanical damage. When you look down your acceptance criteria, you will see that you just have mechanical damage, and it gives a comment, a description, kind of encompassing everything. So in the squares, we're either going to have mechanical damage or we're going to have an arc strike. Okay, and then again at the bottom, we had this bit of undercuts down here. Now I know it's undercut because it's on the toe of the weld, and if I get my nail in it, hoping you can hear that on the stream. Give us a nod if you can. I can get my nail stuck in it basically, so I know there's something there, and we can move on. We can move on from that. So that's that bit there. So that's going to be undercut. Now undercut is interesting in the questions because it can come on a lot of different questions can come around undercut. Right. So the first one we'll do, then we'll get it onto our report first. It's somewhere underneath the mechanical damage. So we'll do that. We'll add our datum. Well, if it's underneath, it's going to be at 105 mil. It is about 10 mil long, and we're going to say it's undercut. Okay. Because it's undercut, we need to have a depth. Now, when you come to use these cam gauges, you can't take undercut depth with these. First real problem is the size of the point on the cam gauge. It's too fat to accurately get to the bottom of the undercut. So really you have to guess, right? But the guess, in all honesty, needs to be, is it bigger than 1 mil or is it less than 1 mil? Okay, and always look at your acceptance criteria. What is it asking? What does it matter? You know, does it matter if it's 0.4 mil of a deep or 0.5 of a mil deep if your acceptance is anything less than 1 rejects or more than 1 rejects? You know, so I'm gonna go, well, I've got undercut. It's less than 1 millimeter deep. And then my last bit of information really for it is it smooth or is it sharp? A lot of the acceptance criteria is based on sharpness. So it could be really deep but smooth and be acceptable, or it can be quite shallow and sharp and rejectable. So we need to make that decision as well. So I'm going to write sharp on there. Okay, so I've got, it's 10 mil long, it's undercut, it's less than a mil deep, and it's sharp. Great. And then we can continue through our sample like that, but just making quick decisions on what we've got is going to be the difference between getting stuck in a loop of worry rather than just making a decision and moving on. Okay? I hope that makes sense, because you see people in exams, and people think it's easy to run CSWIP exams, right? It's soul destroying in a way, because you have to see the people you've taught for a week just disintegrate, and you can't help them, you know? So the best thing you can do is just be methodical. Think about what it is. Where is it? What are you doing, right? So I'm going to talk about defects a little bit more in a second, but once you've got your report, you're going to take your sample and put it to one side, have your report in your hand, and then change to your questions, your multi-choice questions. At the minute, there are 20 questions per, the plate has 20 questions, the pipe has 20 questions. I say at the minute because it's still, the exam is changing soon, but we're still waiting for as lecturers to be given the nod about when that's happening. And the exam completely changes. So remember to subscribe, because when I've already built the videos ready to go live for the new training content for when that happens. I'm expecting it fairly soon, within the next couple of months, but it has meant to be updated for the last nearly 2 years. And there's been lots of things, knock it back. So yeah. Hit the subscribe button, please, and the like, make a comment, get questions. Come on, let's get the algorithm really starting to push this out. Okay, so go to our questions, and the questions look fairly simple, right? So I'm hoping I can bring one up here. Okay, so here I've made these up, right, just to kind of show you how they're built. So question 1, with reference to excess weld metal, which of the following best fits your assessment of the weld? So what you do as you look at your cap height all the way along, you give it a measure with your gauge. If you've not used these gauges or you want some tips on using them, I've got a link to a video in the description below, which just gives tips on making sure how these are calibrated before you do your test, what can go wrong with them, what's right with them. Because they look fairly simple, but a lot of people fail their exams because they don't check their equipment first. Okay, I once saw somebody, well, I once had a question of somebody in an exam who said, you know, I can't get any of these answers. I'm constantly like 3 mil larger on the size than everything in the book. And when we'd looked, the gauge on the top here had moved, so all these measurements were out because he'd never zeroed it and checked everything was right. So have a look at that video. Okay. So I know this gauge is zeroed, so I can come to my plate and then quickly check my cap height. Okay, I measure 2.5 mil, so I know my answer here is going to be 2 to 3 millimeters. So my answer is going to be B, right? And then every question has 2 answers. I now have to look at my acceptance criteria and decide if that is acceptable. So if you look at your acceptance, it'll go excess weld metal height, maximum 2 millimeters. All right, okay. So I'm over that. So I'm then going to select reject. And that's my two marks. The next question is always, well, what happens if I get, you know, the B right, but then I accept it? Will you get 1 mark? And if you get E or F right, but not the A to D, you still get 1. And away you go. So it's still possible to get 50% of the marks, and we need 70 to pass. So you do need to be getting both right at some point. But you take your time, work through the answers. You've already measured it in your report. You're just transferring that report over to these answers. And that's why I'm saying get rid of this if you can, and just work off your report, your answers, and your acceptance criteria, because then you only have 3 bits of paper to contend with. Right? Another example is if we've got undercut. So here we've got, with reference to undercut metal, I've wrote that wrong, which of the following best fits your assessment of the weld? So you can see here, they're not bothered, or the question isn't worried about how much below 1 mil or how much above 1 mil it is, but we've got this this selection of things we can measure, right? So I could say, okay, I'm more than 1 mil and I'm sharp, okay? So I would be B if that's what's on my report. And then I look at my acceptance criteria. Now I know, because I've done it lots, that the acceptance criteria says no sharp indications. So because it's sharp, it's a reject. And I can move on through there and get that to happen. Okay. Hope that makes sense. Now there's 18 other questions built exactly with the same methodology. So you just make your way through them, check it off against your workpiece, and jobs are good. Right. So where people tend to go wrong with this is mischaracterization of defects. So if I just go back up to my report, I'll make myself a bit of room here just by getting rid of all of this. Right. Be logical on how you're assessing defects. Okay. Now, again, people make this more complicated in their minds. Now, the way I teach it is to split the cap and the root in our head. Right. So just for our report here, just because this is a blank piece of paper, I want to say cap defects, right, over here, and I've got root defects over here. Right. Think about what defects are on the cap or on the root. Okay, so if I was to say undercut, well, undercut can be on the cap and it can be on the root as root undercut. Okay. So there's one. They look exactly the same. They can be in both places. What if I said underfill? Underfill can be on the cap, but it is not on the root. Okay. Lack of penetration is on the root, so we could put LOP. Well, there you go. But lack of penetration is not on the cap. So we're always reducing the defects we're looking for in our mind. On the root in general, what we'll see is undercut, lack of penetration, lack of root fusion. I'm abbreviating here, of course, for ease, and concavity. Okay. Maybe a bit of mechanical damage. So something like a tack weld or something that's left in place. But again, I say to all my students, you're likely only going to see, what's that, potentially five defects on the root. If you've got any more than 5 different types, you've done too much. You're looking too hard. You're trying to find defects which are not there. On the cap, so we've got undercut, we've got underfill, we'll have lack of sidewall fusion. Okay. We might have some slag. We'll have our cluster porosity. And our gas pores. So difference between cluster porosity and gas pores. Cluster is lots of bits together. A gas pore is one. Yeah. No real brilliant rules about, you know, what happens if you get 2 gas pores near each other. Is that cluster or is it a gas pore? What I'd say is if you've got the distance here is more than the biggest pore, they're separate. Okay. Just get rid of that. So, still trying to work out this pen for the stuff. I should have a delete button here. Where is my delete button? There. Cool. So, difference between the two. Anything else? Can you think of anything else that would be on the cap? Undercut, underfill, lack of sidewall fusion, slag, cluster porosity. We've got a gas pore. We could have our arc strikes. And on mechanical damage. Okay, but again, if you can make these lists in your head, then we know when we get to the root, well, we've only got 5 or 6. When on the cap, we've got a bit more, but they should be really obvious. Okay, keep that in mind, please, because that's where people go wrong. I cannot stress that enough, that people make this more complicated. They're looking for underfill on the root, or they're looking for gas pores on the root. That's very unlikely. Yeah, the way gas pores form is they tend to head up towards the arc, so they're heading towards the cap of the weld, not in the root. I'm not saying it's impossible to get them. You know, the world is a weird place, and we get the oddballs sometimes. But in the main, you're doing yourself out of marks if you say it's in the root. Which means we might get some really good banker questions in our exam. You might be on the root side in your multi-choice, and they say, with reference to cluster porosity, how much do you have? And instantly, because you can make these lists, cluster porosity is not on the root. I don't have to think about it. Non-observed, accept. Gas pore, non-observed, accept. Arc strike, non-observed, accept. Okay. Underfill, non-observed, accept. And it puts people off because they think, well, I've been asked 4 questions in a row here and they're all non-observed accepts. Yeah, okay. They're randomly generated questions now within the iPads. Anything could come up in any order, which means it is possible, because it's random, that it could be non-observed accepted, non-observed accepted, non-observed accept. If that's your answer, that's your answer. Doesn't matter what was before or after, it matters what you're answering there and then. Yeah. A couple of other things around defects that people tend to struggle with a little bit is the difference between underfill and lack of sidewall fusion and when they appear within the samples. So it is possible to get underfill by itself, but it is not possible to get lacquer sidewall fusion without underfill because of how we're inspecting, because we're visual inspectors, okay? So if I draw my bevel, my single bevel, but my single V, but weld there like that, right? If, I can try to do this in a different colour to make it clear. If I put my weld in, and my weld comes down and round and back up like that, you can see this drop I have from the plane of the plate, which makes this hole here. That is underfill. Okay, nice and easy. Now if I draw again my another single V, and I put my weld back in and do this, so now I have this area here. What I've got here is underfill because I haven't filled my joint up, plus lack of sidewall fusion because I never touched this sidewall here. Okay, so you can see if you say you've got lack of sidewall fusion only, it means somehow you can see through the weld metal and see some sort of defect that's down this face here, and that, of course, that's not possible. And the way the questions are asked, it will ask about them separately. How much underfill do you have, and how much lack of sidewall fusion do you have? So you could undervalue one of them quite a lot by only writing one of them on your report. Hope that makes sense, because that's quite a common thing. And the other one would be, what is the difference between undercut and lack of sidewall fusion? It's all to do with the position of the defect in the weld. So lack of sidewall fusion is a straight line, straight like the side of a scale or the side of a ruler, okay? And it's like that because it's the top or the bottom of the preparation that we've made with a grinder, yeah? So that's the single V or the single bevel, the top of it. So it's straight like a die. Undercut is the burning back of base material. So if we're to look at this bottom drawing again, and I'll try and use a different color, undercut is happening out here, and it's the melting of this material here, which is well away from this area, which is our sidewall. Okay, so we must have completely filled the material to then melt into the material as undercut. If we've got underfill and it's straight, it's got to be underfill and lack of sidewall fusion. Again, I hope that makes some sort of sense, but work through that logic, okay? Don't just blindly try to call everything the worst type of defect. Again, the way the questions are asked, if you mix them up, you mix them up, and you lose marks quite quickly. Okay? So I'm hoping that's okay. I've kind of just tried to get through a bit of practical, this is how you review a practical sample. During your training, you will see quite a few. If you're on a 3.0, you'll probably do 2 plates and 2 fillet welds. During your practice time, potentially even 3. During the 3.1, you tend to do a plate and a pipe, 1 each day. So you do like a plate Monday and Tuesday afternoon, and then a pipe Wednesday and Thursday afternoon. So you'll get lots of practice on seeing these defects and working your way through. On a lot of courses, you're given one of these TWI torches. If you've got your own, maybe better. I find that these are a bit bright sometimes, and sometimes they work, sometimes they don't. You know, the battery is quite short-lived on these, so you don't want to have been going through all week and then find you get to your exam and you can't quite get the right amount of light to cause any shadows on what we're doing. So do that. Check out the video for the gauges, which is below. We've got a slightly older video on reporting and things. That's in the description as well. And crack on like that. I'll give it 2 minutes just to see if there's any questions, and we can. I'm happy to answer them as much as I can. If anybody's busy writing a question out, remember, hit subscribe, please. It's free. The whole point of this channel is not to charge. We're trying to get as much free information out as possible. So if I can get any money back off YouTube, yay, that's great. They pay for our training. And if you haven't already, make sure you check out our April draw video, which came out this week. All you have to do is make a comment in the comment section underneath that video, and we're giving away 4 hours of free training. The way it'll work is you put your name in the video. We'll put them all into one of those name generator circle spinny things online. That's a technical description of that, of course. And with that, we'll pull out the name of the hat. We'll record it all, so it's all above board and it's free. Whoever comes out of it, we'll make contact with. We'll arrange some training next month. So the draw is at the end of the month, and yeah, away we go. We'll have another draw next month, and we'll just try and keep it going and see how we can get the most amount of information out. But with them 4 hours, you'll be able to ask any questions you want, whether it be on theory or on practical, or how weld procedures work. Whatever we can help you with, we'll try and we'll use that time for that. Okay. Right. Well, I'm not getting any questions, so that must mean that I've managed to explain it really well. I hope, because I am seeing people there, or I'm just talking to myself. So yeah, with that then, guys and girls, best of luck. Hopefully, if you've got any questions and you think about anything else later, please just comment, and I'll try and answer as many as I can and I see. I'm teaching this week. I'm actually teaching Pressure Equipment Directive this week, which is always cool. It's legal, how we deal with pressure vessels, how we design them, how we weld them, and all that. But I'll be there and I'll keep an eye on everything. So, right. Best of luck if you start your course soon. And if not, keep watching the videos and keep requesting them. Tell me what you want to know and I'll try and make it. So, hey, with that then, guys, thanks very much. And I will see you all later.